All right, guys, let's take a look at our next examples. Okay, so over here, we have a couple of logarithmic equations that we need to solve somehow, or simplify in the first case and solve in the second case. This is definitely one of the areas that bothers students taking Math 206, and hopefully we can spend some time clarifying some of the concepts over here. The very first thing you should know is the difference between the two examples we're about to solve. Notice that the first one does not contain an equality, so we just simply need to simplify this. And in the second equation, we have this equal sign, and that implies that we have to actually solve for x. Let's take a look at each one of these guys in turn, but before we do that, there's a little bit of theory that we need to be clear about. The notes on the board are definitely also in your course packs, so you guys can follow along. The first thing we're going to do is we're going to learn some properties of logarithms, and here they are. The very first thing that we need to understand is that it is possible to take something in logarithmic form and convert it into exponential form, and thereby eliminating the log itself. This is something we need to be absolutely familiar with. It should be crystal clear. And one way I like to teach this is to convert using something I like to call the Zorro sign. Let's take a look at how that would work. For instance, if I had log x base 2 is equal to, 5, and we want to solve for x or convert this into exponential form, and you're allowed to do this pretty much anytime you want, we're going to use this Zorro sign. If you follow that red line, it'll automatically help you convert from one format to the other. So remember, the Zorro sign always essentially kills the log, or the ln. The properties you see here apply to both logarithms and natural logarithms, or lns. X equals 2 to the power of 5. It is as simple as that. X equals 2 to the power of 5. So the answer for this mini example would be 2 to the power of 5, or 32. And that's essentially what I'm showing here. A equals b to the power of c. So hopefully you guys can understand that. This is something that is important to know for logarithms. Other than that, let's go over a couple of other properties that we should also be aware of. The first property is that if you have log a to the power of m, that is also equal to m log a. Essentially, the power is allowed to come down or go up depending on what is suitable for you in the given problem. So if I have a 3 in front, I can make it into an exponent, or if I have an exponent, I'm allowed to bring it down. The next property that we should know is that we have the ability to collapse logs. It is possible to take many logarithms, in this case 5, and collapse them into one logarithm as long as the base is the same, and it will be for you guys. So the question is, how did I go from here to here? And the answer is essentially you take a look at the sign of the log. If it is positive, it goes on top and gets multiplied by the other terms, and if it's negative, it gets relegated to the denominator. So A and D and E are all positive terms. They go on top and they get multiplied, whereas B and C are negative, they'll go on the bottom. There's a few other properties that you guys could look over. I will go over this one. Log base b of a is log a over b. This is not really a property, but more to teach you how to calculate something in your calculator. The button in your calculator by default is log of 10. So sometimes, if we're given another base, let's say 3, we often don't know how to compute this value in our calculator, so you should understand that this is equivalent to saying log of 5 divided by log of 3. And now you can punch that in and actually obtain a value. This should be sufficient to help us solve the two problems that are given to us. Let's take a look at the first one. So our first problem is asking us to simplify that following expression over there. And in an exam scenario, they will tell you, do this without using a calculator. So that gets a little bit challenging sometimes. We're supposed to do this without using a calculator, but maybe I'll show you how to cheat just a little bit over here to get the job done. So when something like this is given to you, you ask yourselves, okay, what can I simplify, or what property can I apply over here? Well, the very first thing that we can do over here is figure out what this bracket is. Now, for some of us, it's difficult to calculate 3 to the power of 4 minus 6 in our heads. So use your calculator over here. Nobody's going to know that you did that. 3 to the power of 4, guys, is 81, and 81 minus 6 is 75. So that's going to be the first thing that we're going to do. The next thing we're going to do is we're going to ask ourselves, of the various properties that we've learned, which one can we apply? And if you stare at the board for a few seconds, you will realize that one of the things we can do over here is to apply the second property, which is to essentially collapse these logs. Collapse the logs. So I currently have 3 logs over here. I have the ability to combine them into one single log. So the 25 and the 75 are both positive terms. They're going to go up here and they're going to get multiplied. The 3 happens to be a negative term, so it's going to go down here. Now, once again, if this was a problem on your test, the instructors would expect you to kind of know how to do this because they've said do not use your calculator. Once again, if you actually did use your calculator, nobody will know. So that's what we're going to do. If we apply our calculator, if we multiply these two values out and divide by 3, I believe we are going to end up with 625. Let's quickly double check that. So 25 times 75 divided by 3 does indeed give us 625. Now the question is, how can we simplify this further? So this is where our quote-unquote cheating is going to come into play. You are somehow supposed to know that this is equivalent to 5 to the power of 4. And if you have the same base and same value over here, we can apply actually this property you see on the board right here. The answer is just going to be our exponent, or in this case, 4. But the big question here, guys, is how are we supposed to know that 625 is 5 to the power of 4? That's the big question. So here is where we are going to cheat a little bit. We are going to apply this rule in our calculators, and we're going to go from here to here directly first. We are actually, in our calculators, going to type log 625 divided by log 5. And the answer is going to be 4. Now, obviously, this is not something you will write on your exam because you're not allowed to use your calculator. Once you get the 4, you're going to write the middle term down. Now, the middle term will always be log of whatever the base here is going to be the same number here. These two numbers are always going to be identical, and whatever your answer is will always go there. So we're kind of working backwards over here. If you do not have the capacity to just know that 625 is 5 to the power of 4, this is one way to go around this. We know that we can type this in our calculators, get our answer, and then add in this middle term. Once again, the middle term, you recopy the base both here and here, and whatever your answer is goes there. And this way, nobody will ever know what happened. So that's the answer to our first problem. Let's take a look at our second one. So let's get rid of this. Hopefully that was clear for you. Now our second problem, let's bring it up, is asking us to solve a logarithmic equation. We actually have to solve for x here. And in order to do so, there's 5 steps that we're going to apply that work every single time. Let's take a look at these 5 steps quickly. So the first step over here is to bring every term that contains an x to one side and every term that does not contain an x to the other side. So x is on terms containing x on one side and everything else on the other. The second thing we're going to do is we're going to apply that first property we learned about, and if you have a number or a coefficient in front that is allowed to become a power, we're going to do that. Next, we'll have two sides of the equation and we're going to collapse both sides. We're going to combine every log we possibly can and try and have only two terms left over. At this stage, you're going to somehow solve for x. Either you're going to somehow get rid of the logs. So one of two things will happen over here. Either you'll have one log on both sides, and in that case they're allowed to cancel out, or you're going to use that Zorro sign we spoke about to cancel out the log. Lastly, and perhaps most importantly, we always have to check our answer when it comes to logarithms. Let's apply these 5 steps in order to the problem that is kind of given to us. Let's find it quickly. Should be somewhere here. All right, or not. Let's go get it. So our second problem was this guy here. Let's bring that down and apply the 5 steps that we've just learned. So the solution to this problem, remember, step 1, x is on one side, numbers on the other. So what I'm going to do is I recognize that there's an x over here. I'm going to bring that over to the left-hand side. So what that's going to give me is the following. So when it comes over, obviously the sign switches, guys. And everything else kind of stays exactly where it is. So that there is our first step applied. X is on one side, numbers on the other. Step number 2 is to take every coefficient and convert it into a power. We're allowed to do that. That is a property of logarithms. So I have this 2 over here. I'm going to bring it up top, and it's going to become x squared. The second term remains unchanged, but in the following 3 terms, every coefficient is going to move up and become a power. And there you have that. Next, the third step, if you remember, is to collapse the logs. On the left side, I have 2 logs. On the right, I have 3. I have the ability to write those as one single logarithm and combine them. Remember, if they're positive, they go on top, and if they're negative, they go on the bottom. So in my first scenario, the x squared becomes a numerator, and you divide that by x. On the right side, everything positive as the numerator. So this guy is positive, as is the 2 squared. Now this is 4. You can write 4 if you want. I'll leave it as 2 squared for the time being. And that's the end of step 3. 2 more lines should get the job done. So now we have to find a way to cancel out logs, and this is very clear. If you have one and only one log on both sides, they will go away. And this allows us to solve for x. Now x squared divided by x leaves us with 1x. And we could do all of this in our calculators. So on top, this is going to become 8 times 4, which is 32. 32 divided by 4 is 8. I believe that is our answer. This brings us to our last step, which is to always check your answer. And this is done by taking the answer and plugging it right back into the original equation wherever you see x. And asking yourself whether the argument of the logarithm is a positive one or a negative one, because we can't have logs of anything negative or 0. So over here, if I plug in 8, there's something positive here. If I plug in 8 here, it's still positive. But for argument's sake, let's just say one of the terms up there was log of x minus 10. And if that was part of our original problem and we got this answer, notice if you take this and plug it in, you get a negative value, and you can't have that. In that case, you would have had to reject this guy and state that there is no solution to the problem. But for us, that did not happen. The value we got here is the correct one, and that is the answer to this problem. Hopefully, that clarifies logarithms for you guys. Let's move on to the next topic.